Today's show is sponsored by Datadog, a monitoring platform for cloud scale infrastructure and applications. Datadog provides dashboarding, alerting, application performance monitoring, and log management in one tightly integrated platform, so you can get end-to-end visibility quickly. And it integrates seamlessly with AWS, so you can start monitoring EC2, RDS, ECS, and all your other favorite AWS services in minutes. Visualize key metrics, set alerts to identify anomalies, and collaborate with your team to troubleshoot and fix issues fast. Try it yourself by starting a free 14-day trial today. Listeners of the Cloudcast will also receive a free Datadog t-shirt. So go to datadog.com/cloudcast. That's datadog.com/cloudcast.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. Jumping right into cloud news of the week. It's actually a really interesting week for cloud news. This week is less about acquisition funding rounds, which we like to cover here on the show, but more about data. Lots and lots of data and studies. Some really interesting things that are published. So let's jump right in to the first one. The CNCF has introduced something called Technology Radar. And what exactly is it? It's an interesting project, and there's, of course, a link in the show notes. But I'll read straight from the introduction, because I think that explains it really well. Technology Radar is an opinionated guide to a set of emerging technologies. The popular format originated at ThoughtWorks and has been adopted by dozens of companies. And then it basically goes on to put a bunch of technologies in a couple different buckets, such as adopt, trial, assess, or hold. If that sounds interesting to you, there's lots of things in there, such as techniques, platforms, tools, language, frameworks. Really good data points in there to go check out. For our second story this week, we have JetBrains. JetBrains has released a State of the Developer Ecosystem 2020 analysis, and this follows on to a previous developer study I I reported on 2 weeks ago, 3 weeks ago, something like that. And interesting findings here. Java is still the most popular primary programming language. I don't think that's a surprise really to anyone. And Python is the biggest up-and-comer. Again, also I don't think a surprise to anyone. Websites and web backends are also the most popular platforms. Lots and lots of really good data in here. Lots of great breakdowns. And of course, the link is in the show notes. For our third story, there's a really good article on NewStack all about private clouds and infrastructure as a service and how the market is starting to shift. You know, we've of course been covering Azure Stack and AWS Outpost and Google Anthos over the years and following their adoption. But we've always been struggling a little bit with exactly who is using them. What is the current status of the products? We tend to only get the announcements at say the big trade shows on adoption, and with virtual trade shows right now we're maybe not seeing as much information as well. So I felt this article was a really good read for everyone. If this is of interest of you, certainly go check it out. For our last story, we have a really nice project AWS just released. It is all part of AWS Serverless, and it's something called the Innovator Island Workshop. And from reading the README on the GitHub page, it looks to be something that they're going to be using at AWS events. Maybe that is virtual events, maybe that is in-person events. But it is also something you can go do yourself at any time. And I really like this project because it's themed. It's all around putting together a web infrastructure for a theme park. if you will, right? And I find it kind of funny. They put it in here that there is a new theme park being built, but unfortunately, the entire staff has left just a couple hours before it opens. And you have 2 hours to finish assembling all these pieces and get the park open. Pretty neat little project, pretty innovative concept, and really looking forward to working with that as well. And so with that, that is Cloud News of the Week this week, and we'll be moving on to our next guest.
Today's show is brought to you by Taos. Taos acts like a small, nimble company, but has enterprise-level skills and capabilities. That's an actual Taos customer review on Gartner Peer Insights. Explore why the world's best brands trust Taos to solve what's next at taos.com. That's TAOS.com. Taos.com. Today's show is sponsored by Studio 3T. We all know MongoDB is easy. Now make it powerful. Studio 3T is the best IDE on the market to manage your MongoDB databases securely. They take customer feedback seriously, and their users have helped them build features like the nifty import-export wizard, which lets you run, automate, and schedule your import-export tasks easily. SQL, JSON, CVS, and Mongo dump formats are supported, and you can export entire collections or views, current queries, current query results, and specific documents too. Studio 3T's SQL query feature is another great way to save time. Write SQL expressions and joins to query MongoDB and view your SQL queries' equivalent code in multiple languages. If you're unfamiliar with MongoDB language, Studio 3T's Visual Query Builder offers a simple yet powerful drag-and-drop method to find what you need, fast. Get a free 30-day trial, no credit card needed, at studio3t.com/cloudcast.
And we're back. This week we have a really, really interesting conversation. We're going to dig a little further into AI and machine learning. And in order to do that, we have Dillon Erb, co-founder and CEO of Paperspace. How you doing, Dillon?
Doing well. Thanks for having me.
Absolutely. So welcome to the show. Tell us a little bit about yourself and how you got involved in this space.
Yeah. So Paperspace, the company, has been around for about 5 years now. My background is actually a little bit unique. I came by way of kind of the architecture, building architecture and engineering world, and in particular, kind of the HPC space. And that grew into an interest in kind of HPC systems, parallel compute, and became the foundation of Paperspace, which is a company very much tasked with working with kind of emerging accelerators and in particular GPUs to accelerate developers in building out new applications.
Nice. And we'll jump right in here. I've had a running joke on this show that a market doesn't exist until you attach ops to the back of it. So today we're going to talk about MLOps, right? So give everyone an introduction to machine learning operations for those that aren't familiar out there.
Absolutely, yeah. So if you kind of zoom out and look back over the last say 5 to 10 years, we've seen the emergence of some really amazing technology in the machine learning space. So obviously, machine learning is kind of a moving target, but the emergence of this thing in particular called deep learning, which powers things like driverless cars and voice recognition and recommendation systems, has really become extremely advanced. And so as that's happened, there's really been a need for kind of traditional software engineers and kind of standard software development practices to blend with the machine learning world. And so, there are a few key differences between kind of machine learning and traditional software development. We can kind of talk about those. The biggest of which, at least that we focus on, is the fact that, machine learning in many cases requires pretty substantial compute resources. So, you can develop an iOS app or a web app on your laptop, but once you start getting into more advanced machine learning, it really requires that you start provisioning kind of large clusters of GPUs, and so that kind of is the main piece that I would say differentiates kind of traditional software development from kind of this new machine learning and AI world.
Yep, makes sense. And there's also, kind of looking through the website and some of the blog articles, and we'll put links out to some of those as well in the show notes, but there's also this concept of a serverless AI platform. And, we've covered serverless pretty in depth on this podcast at times. And so our listeners should be very familiar with what serverless is. But how does that, when as an AI platform, how does this differ from say, traditional CI/CD platforms, or that our listeners may be used to, or is this all about just abstracting away the infrastructure layer for MLOps teams? Tell us a little bit about the under the covers of what all of that means.
Yeah, absolutely. So, the idea of serverless at a high level is that, you can abstract away hardware in a way that, you are just interacting with kind of high level primitives. So you're saying, I want to do this task, and then the platform that you're using will, delegate that task and figure out where to execute it and deliver results to you without you actually kind of diving into it. So at the core for us is, actually the idea of containerization, which is, as very common in kind of web development, and we rely on it for our web application. And so everything is containerized, which means that when you submit a workload, say I would like to train this machine learning model, what we do behind the scenes is fire up the machines, create the storage and networking components, and deliver to you really what you're asking for, which is just kind of the results of that execution task. So very practically, what that means is you can download our CLI or use our web console and submit a task to the cluster, which is going to process all of the compute. And under the covers, we're going to do all of the pieces that you would have to do manually, from provisioning those containers to connecting them if you're doing something like a more advanced multi-node or hyperparameter sweep, which are kind of machine learning specific applications. And so the idea of serverless is, I think, kind of twofold. One, it's a kind of methodology that says a machine learning person or a software engineer should not really be tasked with doing all of the kind of underlying networking and hosting logic, but really that should be abstracted away.
Yeah, that makes sense. And if we switch gears for a second, because you have mentioned developers here, and if we switch gears from ops to developers, what do you mean when you say you make it easy for developers to use GPUs, and kind of combine that maybe into the previous topic as well? And what do developers need to know about hardware stuff, that like GPUs typically?
That's a great question. Yeah. So if you look at, you mentioned kind of CI/CD, which is, the dominant paradigm for software development today, and I think has led to, a lot of really amazing applications being possible. And at the kind of core of CI/CD, or continuous integration, continuous deployment, is the idea that you can set up a deterministic process that goes from sort of end to end. Like, I'm going to develop this model or this application, I'm going to deploy it, and every step in between is actually well defined. So there are lots of traditional CI/CD tools. There's Jenkins and Circle CI, and a lot that are very well understood. But if you start kind of unpacking it for the machine learning world, there are some kind of large fundamental differences. So in the biggest one we kind of mentioned is that everything's not just running on kind of a standardized x86 CPU architecture. In fact, most machine learning kind of pipelines have different accelerators at different components. So you might train on a GPU and then deploy onto a CPU. So fundamentally, the pipeline itself has to acknowledge the fact that it is running on very different hardware topologies. In addition to that, I think containerization is a really important piece as well. And whereas containers have become very common in web development, they're still relatively new in the machine learning world. So what that means for a developer is a container that you're running on your CPU or a Docker container locally is not going to run the same on a NVIDIA GPU server. And so there are a lot of kind of mixing and matching kind of pieces you need to make sure that you have the right driver versions, the right dependencies, the right connections to all of the hardware that underlies it. And it can get pretty complex once you start building out more advanced applications.
And what kind of tools? So you mentioned this kind of transition away from, if you will, the CI/CD, the more traditional CI/CD platforms, and tell us a little bit more about the pipeline and the tools and what that looks like end to end. If, say, I'm a developer.
Yeah, so I think that in the machine learning space, we're in this kind of interesting position, kind of broadly, the industry is, where the algorithms are getting more and more advanced, the tooling is getting more advanced, but there's still a pretty big gap between being able to, say, train a interesting machine learning model on your local computer, say using PyTorch or TensorFlow or one of the more kind of common libraries, and then actually deploying that into a production system. And so the pipeline itself, in addition to running on different hardware, there's new primitives in it. So it's not just code that's coming in, but actually data is a very important piece. And so these are components that you actually want to track. And ultimately, kind of the holy grail here for anyone working in sort of the ML AI space is that you want to create a end-to-end kind of pipeline that is actually continuous and retrains itself, meaning you train a model that gives you a prediction, you deploy that model, you observe how it performs, and ultimately you want to use that data to kind of connect the entire loop and retrain that model continuously as new data is coming in. So that is, still very difficult for people to do, and MLOps I think is a kind of a term that used to capture that process, which is you've got these people building out machine learning models in TensorFlow and PyTorch, which by the way mostly is done in Python, and then you have the DevOps folks or the people responsible for deploying applications at a company or an organization, and they're really using things like Go and Kubernetes and traditional kind of web development stacks. So MLOps is really like the interface between those two worlds.
And so oh gosh, you bring up some interesting points here. I'm trying to figure out where to go next. So I'm thinking about the models themselves. So in an ops world, tell us a little bit more about those models, right? Like if I'm a developer and I'm developing a model, and to your point, I'm ready to promote it, or I want to spin it off into others. And like, I have in my head of like, okay, you've got one big model, one model to rule them all, or you've got a bunch of smaller models, and how does that decision tree or flow work from a model standpoint in managing all of those models and outcomes?
Yeah. So I would say two things. One, any platform that kind of works in the MLOps space is really, the model is kind of the centerpiece. It's the primary artifact that comes out of the system. Whereas in a web app, your artifact might be the static build of the application. In the machine learning space, the model is really the fundamental kind of output. And so even the idea, I think luckily the kind of CI/CD language and methodology is really helpful here, because if you look at any kind of modern agile software development company, they're going to have distinct dev, staging, production environments. They're going to have special rules for when to promote something from development to staging to production and roll back, and there's really a rich language around it. In the machine learning space, it's still relatively new, and so largely what we're doing is kind of bringing the best practices of traditional software development and applying that to the machine learning space. Meaning, you can have multiple dev, staging, production environments. In the machine learning world, that could mean, my local environment is actually a GPU cluster under my desk, but my production environment is a hyperscaler cloud environment like GCP or Azure. And so, there's been some interesting language kind of come out recently in the DevOps world around kind of what they call the inner loop of development, which is how do you create reproducible local environments that you can then scale out to larger cloud systems. And I think that's a really helpful kind of language to use for understanding why it's so important to have a platform like Gradient, which is our MLOps platform, to manage the entire thing for you.
Yeah, Dillon, that makes sense. Now, as with everything emerging tech, I'm always interested in use cases, right? And use cases are constantly evolving. And
yep.
What were some kind of the early initial use cases you're seeing, and what are some of the applications? And then is there anything kind of unique here that's emerging? For instance, I was going through the website, like gaming or media applications or some of the other things in this space.
Yeah, so I think at its core, there's a question of like where does deep learning start and regular machine learning end? And the big kind of advantage that GPUs provide is they're really good at operating on lots of data, and in particular, the kind of killer application has, at least in the near past, has been computer vision. And so what that means, that means like a driverless car looking at lots of video feed of its surrounding environment. And that's the kind of thing that traditional data science just really can't operate on. You can't use kind of traditional data science to build out these really powerful predictive models out of especially video or image data. And so there are actually some really, it's not exclusively for that. You can actually use deep learning for everything from recommender systems to fraud predictors. But I would say computer vision is, at least for us, has kind of been the most common application. And so the media, kind of media generation, I think there's a the kind of traditional scope of GPUs, which they stand for graphic processing units or graphical processing units. We're seeing a really interesting kind of blend of those worlds where you can actually use machine learning models to generate images and video. We've seen sort of the emergence of things like deep fakes, which are kind of bizarre generative models that come out of the machine learning space, but are very much around kind of media production. So yeah, I think there's a lot of emerging applications. The things that I think are particularly exciting are ideas around. There's this thing called reinforcement learning, which is basically you can. Well, I'll mess up explaining it, but basically you're using training a model that is operating in an environment and building out kind of more advanced predictions. And also there's this idea that's kind of emerging around synthetic data, which is, can you use a machine learning model to actually generate the data that's then used to train other machine learning models? So there's a lot of really interesting kind of emerging applications here. And the use cases today, I would say, are still, not entirely computer vision, but certainly computer vision is one where you need something like a deep learning tool stack. And we're starting to see that trickle down into every application. I mean, at the end of the day, a machine learning model will likely, replace any other kind of traditional heuristic you might have. And for that to happen, you need to really democratize these tools and make them more accessible to, say there's only 10,000 people that are deep learning experts. Well, what about the rest of the kind of software development world that wants to onboard to this tool?
And how does the access to the data models fit into this? Is it like bring your own data model? Is it you provide the data models? Is it go out to the big public cloud repositories for data models? Like, tell me a little bit about the training against the data models.
Yeah. So data is they call it the kind of the fuel that you need to power machine learning. You need the kind of the primary pieces are the code that you're running, the kind of runtime or the container or the software frameworks that you're using, and then the biggest piece is the data itself. So data can come in lots of different forms. I think we're actually in a really good spot today, which is that many companies have invested in collecting large amounts of data, especially structured data. And so now you can actually operate on that. So data, there are some kind of particulars to it. There's kind of two primary types today. There are kind of traditional file systems that are used. You might want to mount like a large directory of image files or video files. And then I would say more common today is actually moving to using sources like S3, object stores in the cloud, where you can begin to operate on these things in a more kind of cloud native way.
Nice. And speaking of data, I'll finish up with this one. I noticed your company did some articles on COVID-19 and can you explain to everyone a little bit about what is going on there, since it tends to be top of mind right now?
Yeah, so I think that obviously the COVID-19 kind of research domain is pretty massive right now with a lot of interest, and where we've been working is trying to find ways that we can apply these tool stacks to analyze large amounts of data. So we've seen new data sets coming out, especially around like lung data. And the idea is that, can you build out a tool that's more predictive than maybe a physician who's, operating in the heat of the moment. There's also all sorts of other modeling that can be done. Ultimately, if you think about a problem, like a pathogen or, something really complex like global warming, the only tool that we have today that is probably sufficient to model these things really is machine learning and deep learning, because fundamentally what they're really good at is taking very, very complex data, interactions and building out kind of predictive models to say, here's what we think is actually happening behind the scenes. And so, I don't know if kind of machine learning will quote unquote solve this, but it's certainly an area of active research, and we've been working with research teams, universities, and individuals who are trying to apply this these tools to drug discovery, prediction, and everything in between.
Fantastic, Dillon. Now, like I mentioned, we're about out of time. So, Dillon, where can everyone find out more about you, find out more about the company, and everything y'all have going on?
Yeah, so we are very, like we had said at the beginning, very developer focused, which means that you don't have to go through sales to use this. We actually have anyone can sign up with a Google or GitHub account and start training models today and learning the system. We actually provide free GPUs to run on as well. So if you'd like to create a free account, you can just go to paperspace.com or gradient.paperspace.com. And we have a ton of resources for getting started and beginning to onboard this technology.
Fantastic. Dillon, thank you so much for your time this week. And on behalf of Brian, who wasn't able to make it this week, thank you everyone for listening. And we'll talk to everyone next week.
Awesome. Thank you, Aaron.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.